All right, so we're starting with number 12. I think it was D block. Maybe it's either A or D block that did this. That's difficult because they're the other two blocks. But what altitude above the Earth's surface is the gravitational field strength equal to G over 5? All right. So it's a gravitational problem, so of course we're going to do a general Y. We can do a diagram, but all we really need in there is words, because remember, the rubric there for my general problems. So this is number 12. I think one of the key understandings to make sure that it's clear you understand in this problem is actually the term altitude. Can anyone tell me or give me a good working definition of altitude? Can anyone give me a Google definition? You all have devices in front of you. Maybe someone could Google it and tell us what Google says altitude is. What you got, Luke? Luke got, sorry. Vertical elevation of an object above the surface. That's kind of nice, yeah. So I'm just going to put that for rate of altitude. Oops. Spell it. Is vertical elevation, and I might even say distance there, above surface. Okay. So the other things are in here are about gravitational field strength. What creates or what influences the gravitational field strength? Do we have to have two objects to have gravitational field strength, gravitational field? No, we only have to have one, right? So it's how far you are from the center of mass of that object? Yeah. What happens if that distance gets bigger? The gravitational field gets weaker, right? So you want to show something about that. Something like grav field on how far from center. What thing are we dealing with here? Are we dealing with a planet? Are we dealing with a specific planet, an asteroid, a chicken? Which one? Earth. Because you want to make sure that you tie it back to this specific problem, right? So I'm going to also add in there further, weaker. Anything else influence or the gravitational field? Anything but about the Earth that would make it bigger or smaller? The mass. Mass. The mass of Earth changes. Grav field. Oops, that was 13. Field. More mass, more force. More strength. I'm going to add one other line in here, just dependent on Earth, not the satellite. So I think it's clear. You want to make sure you understand that gravitational fields are created by the one object. Gravitational forces are the interaction between two objects. So you want to show that you understand that distinction. How do we do on the Y? What do you think? Good? All right, let's get down to the how then. I'm going to start my how with the diagram just to remind myself that I've got the Earth here, got my satellite up here. This would be the radius of the Earth. This would be my altitude. What variable do we want to use for altitude? A. Okay, let's use A. Capital or lowercase? Lowercase, okay. We're going to use lowercase a for altitude. All right. Now we need to start with a valid equation. So those are always on my valid equation sheet. And the one that has to do with gravitational field strength is down here in this corner. And that's general for any planet. But I know what planet I'm dealing with, so we'll put it in here. And that's big G, mass, in this case the Earth, over radius squared. And this is the part that a lot of people will make a mistake on. That R is this distance here. How far apart the center, from the center of the Earth to where the point we're interested in. That's the R in that equation. If I'm on the surface of the planet, of course, that's just the radius of the planet. But in this case, it's how far apart they are. Because I'm not on the surface, I'm above the surface. So now they want us to find A, I think, right? The altitude. Okay, so we should substitute in what we know. Let's see. We know that this is little g over 5. Because looking at my problem, at what altitude above the Earth's surface is the gravitational field strength equal to little g over 5? Big G, and this would be the mass of the Earth. That's the thing creating the field, and this is going to be A plus radius of the Earth, quantity squared. Now, at this, did I lose anybody in substituting in? Good. So now at this point you have a choice. We know we need to solve for A. I know what little g is, because that's 9.81 newtons per kilogram. Got it on my equation sheet and on the wall. I know what big G is. I've got that on my equation sheet. I know the mass of the Earth, so I have that on my equation sheet. I know the radius of the Earth, because I have that on my equation sheet. So all I'm left with is what they asked me for, A. You kind of have a mathematical choice to make here. I can plug in all the values I know, and I'd just be left with A, and then I can solve for A, algebraically. Or I could use those algebra skills I have to rearrange this to get A equals, and then plug in all my values and solve for A. Both ways work. Whatever's your preference. I mean, your other option would be to put in all your values and then use one of the solvers on our links page, like Wolfram Alpha would be the one I would probably use. And I'd put it in and I'd solve for A. Let it solve for A, and me not have to play with algebra. So you kind of have to make a decision which way you want to go. All right?
Oh, so how would you do that with the solver?
You type it in using how they want you to type it in. Yep. I wasn't going to, because you have all these values. And now it's just algebra, and quite frankly, this is physics, not algebra. So at this point, we're kind of the physics is done, and now it's just, can you do algebra?
What's algebra equivalent to
9.81 newtons per kilogram. Yeah, and so we know little g, 9.81 newtons per kilogram. We know big G is 6.67 times 10 to the negative 11th Newton meters squared per kilogram squared. I can go onto my equation sheet here and grab the mass of the Earth, which is right down here. Mass Earth, 5.98 times 10 to the 24th. Kilograms. Radius of the Earth. Oops. Radius Earth, 6.38 times 10 to the 6 meters. So 6 million. I mean, it's always good to also check, do all my units line up? Newtons and kilograms, Newton meters, kilograms, kilograms, meters. Yeah. So I don't have to convert anything at least. And then just solve for A. However mathematically you want to solve for A. I need a center of mass setup. That's a normal setup. Alright, so here's my center of mass Y setup, where I can look at my rubric, and I need to show the situations correctly. I need to make sure I have all diagrams and locations required shown. I need all masses or forces shown and correct, and I need my labels to be easy to understand. Pretty straightforward. So I'm going to have two diagrams in this problem because I have the Earth-Moon set up here, and then also Moon, Earth, and Sun set up here. All right? So I'll start with the Earth-Moon. And so I'm going to put the Moon right here. I'm going to put the Earth here. So that would be the mass of the Earth. This would be the mass of the Moon. This would be radius from Earth to Moon. They said take this point as my 0 point, right? They said use the center of the Earth as 0 point. So where do we think the center of mass would be? In the Earth? No, not of the Earth. I'm sorry, the two of them combined. Because the center of mass of the Earth is going to be here. Center of mass of the Moon will be here. What about the two combined? Where do we think the center of mass would be? Good? Okay. So that's how I indicate, and that I would label it like center of mass. And that means this distance is xcm. I don't need to do this, but I'm going to take that direction as positive. Now I need my other diagram, though. I had the Moon, the Earth, and the Sun. So this was the mass of the Moon, This is the mass of the Earth. This is the mass of the Sun. This would be radius Earth to Sun. This would be radius Earth to Moon. They said take this point as 0. Where do we think the center of mass would be for those three things? Any guesses? No? All right, I'll guess. I'm going to guess here. Maybe wrong, but I'm going to guess there. And so that's my XCM, the distance from 0 to that center of mass. Location of that center of mass, excuse me. So let's see if I hit my rubric. All situations shown correctly. I think so. Diagrams and locations required shown. I showed where all my objects were. I have both diagrams. I'm good. All masses shown and correct. Moon, Earth, Sun. Yep. Labels on diagram, easy to understand. I think so. I matched up my colors and things like that. So. Good? I get it? All right, let's do the first part then, which is the moon and the Earth. So down to my house. So part A. And I'm going to grab my valid equation, which says XCM equals, remember, here it is. Oops. It's got the M1, X1, M2. How many different things do I have in this problem? How many objects? I'm looking for the center mass between the moon and the Earth. I'll stop asking questions. I'm stumping you. I know. 2, the moon and the Earth. So I'll just go. Don't worry about it. Mass of the moon, location of the moon, plus mass of the Earth, location of the Earth, over mass of the moon, plus mass of the Earth. All right. Good. And now I'm just going to substitute in XCM. What I want to know, mass of the moon. Get that from here nicely. 7.35 times 10 to the 22nd. Kilograms. Rotation. Radius. Earth to moon is 384 times 10 to the 6th. Meters plus mass of the Earth. I should know that by now. Times 0. All over. Yeah, the only thing I don't know is what I want to know. That always makes me happy. Moving on to B. In B, I have 3 things. If you have questions, ask. If you don't? Don't ask. Breeze, Earth, Moon, Regis. Earth, Moon. Oh, I'm running out of space. Keep going. Plus. Sorry, let me finish this number and then I'll answer your question. What was your question? 149.6 times 10 to the 9th meter. Questions?
The last top right, so 149.6 is that
Times 10 to the 9th meters. Yeah, see, it's a repeat of this number. Cool. Yes, ma'am. Ma'am.